After a rare and prolonged sandstorm, researchers monitoring the dried salt basin in North Africa noticed a sharply defined vertical shadow in new satellite imagery. Across several frames taken days apart, the shadow remained perfectly still, too precise for a dune or dust column. The coordinates pointed to a barren expanse where older maps showed nothing but cracked salt crust and the faint traces of ancient tire tracks long buried beneath drifting sand. A 5-person team, 2 radio engineers, a surveyor, an electrician, and a driver, set out at dawn. On the horizon, the object first appeared as a thin line, then as a vertical cylinder, seemingly planted in the salt. As they drew closer, details emerged: iron railings, a lantern crown, and the segmented glass of a Fresnel lens. The structure rose from a shallow mound, half buried by fresh sand. At the base, under a crust of salt, they found an inscription: L13. Above it, a corroded plaque bore the French words, station and signalization, the numbers unreadable. Flakes of worn paint revealed 2 layers: gray over faded sea green, a shade once used on marine buoys. Every detail implied not randomness, but purpose, the remains of a system once maintained and operational. They climbed the external spiral staircase carefully. Each step creaked, but held. The platform above was intact: rusted railings, mounts for lighting equipment, and a cylindrical lantern housing with concentric prisms. Inside the shaft stood a steel control panel with round analog gauges, ceramic insulators, and knife switches. Several brackets were empty, as if equipment had been deliberately removed decades ago. If you find this discovery interesting, subscribe, leave a like, and comment where you're watching from. I read every comment. The first inspection revealed no signs of recent presence, no litter, footprints, or tools. On the leeward side, they found a threaded socket sealed with salt, likely the mounting for an old antenna. Weld seams suggested mid-20th century construction, yet the materials pointed to something more advanced: aluminum reinforcement instead of steel, and ceramic cable sleeves meant for high-voltage systems. Near the tower's base, they uncovered a thin armored cable. Its insulation was cracked, but the sheath remained intact. The electrician removed the panel's cover, probed the terminals, and connected a portable multimeter. The needle jumped immediately. There was a measurable potential difference between input and ground. Repeated testing with a ballast resistor yielded the same result. Somewhere below the desert floor, power was still flowing, faint but steady. The wind brushed against the lantern glass. The lens caught a fleeting glint of sun. The evidence formed a logical, yet baffling picture. Before them stood a lighthouse, complete with maritime optics, balcony, identification mark, and control unit. Yet there was no coastline here, no sea within hundreds of kilometers. To rule out induction, they attached a resistive load for several minutes. The voltage dropped slightly, then stabilized again when disconnected. It wasn't residual charge or electromagnetic interference. It was an active line buried beneath the salt. On the shaded side, the dig exposed a narrow ventilation grill with traces of mesh. From it came a faint draft of cool air, proof of a cavity beneath the tower. Near the stairs' footing, a small hatch, sealed by salt, suggested access to a cable duct. Everything pointed to an underground chamber, not just a foundation, but a functioning service room, once housing a generator or power relay. The finding was simultaneously simple and impossible. In the heart of a lifeless basin, surrounded by dunes and salt crust, stood a full-scale lighthouse of maritime design. It had been engineered with precision, equipped with optics, cables, and plaques. And despite decades of isolation and heat, the control panel still carried power. Somewhere under the desert lay a source that had never been shut off or recorded, and the story of this lighthouse had only just begun. When the upper railing was cleared of salt crust, a faint outline appeared beneath the corroded metal. Fragments of a colonial emblem, a shield, a laurel branch, traces of French lettering. It placed the structure somewhere between 1940 and 1960, during the last years of French North Africa. The researchers contacted archival centers in Marseille and Algiers. None of the records mentioned a lighthouse, beacon, or even a signal tower at these coordinates. The area had never bordered water, and no inland navigation routes were known to exist. The first assumption was practical. Perhaps the tower had served as a land-based marker for aerial navigation, similar to early aviation beacons installed across the Sahara for mail planes in the 1930s. But those were skeletal steel towers with acetylene lamps, not reinforced concrete cylinders crowned with Fresnel lenses. The structure before them looked far more sophisticated, too heavy for a simple marker, too isolated for a communications relay. Material analysis deepened the mystery. Core samples from the outer wall revealed a composite mix, a cement bonded with fine aluminum powder and silicate ceramics, forming a lightweight but heat-resistant shell. Such technology was far beyond typical 1930s colonial engineering. The team's metallurgist noted that this type of concrete began appearing in France only in the late 1950s, primarily in experimental military facilities. The lens housing, cleaned of sand, bore serial engravings used by marine manufacturers, numbers corresponding to coastal beacons produced in Brest and Toulon. That detail was impossible to ignore. Someone had transplanted maritime components hundreds of kilometers inland and mounted them atop a tower in the middle of a salt desert. The archives offered a partial clue. A 1956 report described a station optique expérimentale planned somewhere in the interior plateau for high-frequency orientation trials. But no coordinates, no photographs, and no reference to construction material survived. The document was unsigned and stamped Projet ajourné, postponed indefinitely. One theory proposed that L13 might have been a prototype for geodetic alignment, a fixed optical axis used to calibrate aerial mapping instruments. Another suggested a more atmospheric purpose, measuring light refraction over flat terrain, perhaps for early missile telemetry. Yet none of these required a working electrical line or a lantern lens capable of projecting light. Then came the most tangible clue. At a distance of 50 meters south of the tower, one of the geologists uncovered a curved fragment of oxidized metal half buried in salt. The shape resembled the collar of a buoy or navigation float. Along its rim, worn but legible, were the markings S Infrared. Laboratory cleaning confirmed it belonged to a maritime buoy manufactured in 1958. The fragment's presence in the desert was not just puzzling, it was contextually absurd. No flooding had ever reached this plateau since prehistoric times. The nearest marine sediment was over 400 kilometers away. The team could only conclude that the buoy had been deliberately transported here, perhaps as part of the tower's construction or testing phase. Meanwhile, the electrical anomaly persisted. Even after 24 hours, the voltage on the panel remained measurable. When disconnected overnight, the charge returned the next morning at identical levels, indicating a continuous external feed rather than trapped residual current. As daylight faded, the researchers gathered their notes in the shelter of the supply vehicle. Their data were internally consistent, yet logically contradictory. A concrete lighthouse of marine design, constructed with advanced post-war materials, bearing colonial insignia, powered by an unknown underground line, and situated hundreds of kilometers from any navigable water. No known project fit all parameters. Every explanation, geodetic, meteorological, or military, left gaps wider than the desert itself. The site looked engineered for signaling, not observation. And if it was meant to signal, the obvious question arose. To whom? That night, as the temperature dropped below freezing, the lens of L-13 reflected the moonlight like a silent eye, staring westward toward the invisible coast. Somewhere beyond the dunes, the answer waited, buried under layers of time and sand, and the team decided they would start digging at first light. They began digging at dawn, focusing on the shadowed side where the sand was still cool and compact. The plan was simple: trace the armored cable discovered earlier and follow it to its point of entry beneath the tower. Within the first hour, the shovel struck something hollow. Clearing it carefully, they exposed a rectangular metal grill, a ventilation vent half blocked by crystallized salt. When they brushed it open, a faint draft of air escaped, dry but cooler than the surface heat. That single breath proved what they suspected. There was a chamber beneath the lighthouse. By midday, after clearing nearly a meter of sand, they uncovered the top edge of a heavy steel door, its hinges fused with rust. The handle crumbled under pressure, but a crowbar loosened the seam just enough for a flashlight beam to slip through. Inside, light reflected off metallic walls, the unmistakable shape of a confined mechanical room. After widening the opening, one of the engineers squeezed through and descended onto a layer of fine dust. The room measured roughly 4 by 4 meters, cylindrical like the tower above, with a low ceiling. In the center stood a squat engine, a diesel generator, its flywheel frozen and casing furred with corrosion. Thick cables led from it into a conduit, disappearing into the far wall. On the opposite side, bolted to concrete, was a steel control desk with gauges, dials, and a paper label holder. A dim brass plaque above it bore the inscription, Projet Semaphore 12. On a rust-stained table nearby lay a small box, steel, sealed with 2 broken latches. When opened, it revealed a stack of water-damaged folders, bound with twine, and a thin metal access card engraved with a lightning bolt, and the letters SRAF, Société Radiométrique Française. The engraving was fine, professional, the kind used in laboratory identification rather than military tags. On the reverse side, etched with a stylus, was a narrow strip of numeric code, frequencies and hourly intervals. The papers inside the box were in French, their corners fused by salt. A few pages remained legible, tables of signal timings, notations about synchronization radio, and a typed paragraph referencing Post L1 L14. The meaning was vague, but one line stood out. L13 active, transmission test en cours, supervision, Défense Nationale. At the bottom, an ink stamp, Ministère de la Défense, classifié. The electricians examined the wiring. One bundle of cables traveled downward through a conduit drilled into the bedrock. Another rose vertically toward the control panel upstairs. A third led horizontally toward the west, precisely in the direction of the distant coast. The craftsmanship was exceptional. Porcelain insulators, perfectly crimped junctions, and still shining copper under a film of oxide. This was no field improvisation. It had been assembled by skilled technicians using standardized military components. Testing the continuity of the cables yielded astonishing results. The vertical line to the tower was intact, the resistance negligible. The horizontal line, leading west, carried a weak but measurable current, proof that the power source was external. Something out there, far beyond the dunes, was still connected. One of the engineers flipped the corroded knife switch on the lower control panel. It refused to move at first, then clicked halfway before freezing. A faint buzz trembled through the casing, the sound of live contact. Everyone froze. It wasn't enough to illuminate a bulb, but it confirmed their suspicion. The circuit was not dead. They spent the rest of the day documenting every surface. Stencils on the wall, serial numbers, calibration notes. Under a layer of grime, they found a painted arrow pointing toward the floor, accompanied by 2 letters. U6, west. It corresponded exactly to the direction of the cable trench. By evening, the air inside the chamber had become stale. They sealed it again to prevent collapse, leaving sensors behind to monitor temperature and residual current. Outside, the sun was setting over a vast expanse of ochre dunes, the tower's lens glinting faintly in the fading light. For the first time, the discovery felt less like an archaeological curiosity and more like an incomplete machine, a dormant node of something once immense and coordinated. The presence of official military stamps, classified notations, and references to numbered stations meant the lighthouse had not been built in isolation. It had belonged to a network. And if L13 was one of 14 points on a larger map, the question was inevitable. Where were the other 13? Back at their temporary camp, the researchers spent 2 nights sorting the documents rescued from the underground room. Most were ruined by salt and heat, but a few fragments could still be read. Combined, they outlined a forgotten French program from the 1950s called Projet Semaphore. Its stated goal: to establish a chain of terrestrial lighthouses, radio signal beacons meant to guide aircraft across the Sahara, forming a navigation corridor from the Mediterranean to sub-Saharan colonies. Each beacon was assigned an L code and operated autonomously, transmitting a steady frequency detectable by onboard instruments. According to the notes, the network was to consist of 14 such stations. Construction began in 1955, with sites selected for their high visibility and geological stability. But in 1959, after an unexplained accident, the project vanished from official reports. Some of its personnel were transferred to other divisions. Others simply disappeared from payrolls. None of the stations were recorded as dismantled. To verify the story, the team contacted historians specializing in Cold War aviation. Most had never heard of Semaphore. One professor recalled a brief reference in a declassified aeronautical manual from 1961 mentioning experimental terrestrial navigation relays, now defunct. Nothing more. The physical evidence on site, however, contradicted that last statement. When the team powered a wideband receiver and scanned near the frequencies listed on the metal card, they detected a faint but persistent signal at 171.8 Morsen. It came in soft pulses, repeating every 62 seconds. Too regular to be natural, too clean to be random interference. At first they suspected local electronics or atmospheric reflection, but triangulation eliminated both. The signal's source coincided precisely with the base of the lighthouse. Yet its content was strange. Instead of continuous carrier waves, typical for navigation aids, it emitted a coded burst, a sequence of short and long pulses separated by exact time intervals. When they plotted it as binary data, the numbers aligned into pairs resembling geographic coordinates. The coordinates pointed not to their current position, but to another region hundreds of kilometers to the west, across the dunes, toward the coastal strip once controlled by the French Air Force. The message seemed to say, "Reference L13 to L14. The discovery reignited the team's debate. The project might have been far more than simple beacons. The combination of radio and optical systems suggested a hybrid method of calibration, radio triangulation, synchronized by light reflections. If accurate, Semaphore could have served as an early precursor to satellite navigation, decades ahead of its time. But there was another, darker possibility. The Defense Ministry stamp and the classification mark secret implied military intent. During the late 1950s, France conducted atomic tests in the Sahara. Accurate airborne navigation would have been critical for sample recovery and monitoring flights. Could these lighthouses have been part of that infrastructure? A covert grid for coordinating nuclear logistics? The engineers studied the electrical data again. The cable leading westward maintained a measurable voltage drop consistent with a powered line, meaning that one or more stations in the chain were still connected. No modern grid extended this deep into the interior, leaving only one logical explanation: an abandoned, isolated circuit still energized through forgotten conduits. As night fell, the team set up a directional antenna on the vehicle roof. When pointed toward the source of the transmitted coordinates, the signal's amplitude increased slightly, confirming that L13 was not only broadcasting, but also responding to distant impulses, as though it were part of an automated handshake with another node still active. They replayed the data repeatedly. Each burst contained minute variations, like a ticking heartbeat encoded in Morse precision. Every 62 seconds, a pause, then another pulse. The timing was immaculate. For decades, the desert had buried it. Yet here it was, a functioning fragment of Cold War engineering still whispering into the ether. The team watched the oscilloscope trace rise and fall in perfect rhythm, aware that what they were seeing defied the logic of decay. The station wasn't dead. It was waiting. The coordinates embedded in the 171 signal led the team hundreds of kilometers west, across featureless expanses of ochre dunes. Satellite images showed nothing but sand, yet subtle tonal variations hinted at buried geometry. After 2 days of travel in convoy, the vehicles halted on a shallow rise, where the georadar began to register a smooth, curved anomaly beneath the surface, too regular to be natural. They began digging where the signal strength peaked. Within hours, shovels struck something hard and cold, a circular concrete surface, slightly domed, its texture identical to the base of L13. As the sand was cleared, a shallow depression revealed itself, the rim of a structure buried entirely under desert sediment. What emerged was not a tower, but the flattened top of a bunker-like vault. At the edge of the dome, the team found the remains of a twisted metal frame. Once it might have been an antenna array. Corroded brackets, sections of copper tubing, and ceramic isolators similar to those in the first lighthouse. Half-melted wires still ran along the curvature of the wall, disappearing into the sand. Despite decades of exposure, the construction was intact. Cast concrete reinforced with the same aluminum alloy mesh seen before. Using portable instruments, they measured residual conductivity across the surface. The readings were faint but consistent, current flowing in one direction, westward. Tracing the buried cable lines confirmed that multiple conduits left the dome, merging into a single trunk that stretched toward the distant coast. The discovery supported their growing theory. The lighthouses had been nodes of a continuous chain, all wired together like organs in a dormant body. While examining a partially exposed hatch, they encountered fragments of a corroded label, only 2 words still legible: Station L14. The match was undeniable. The pulses from L13 were pointing directly to its successor in the sequence. Attempting to enter the interior proved impossible. The hatch was sealed by hardened salt. Instead, they inserted a fiber optic probe through a narrow crack. On the screen appeared a confined space filled with collapsed metal scaffolding, sand, and remnants of machinery. Switchgear boxes, collapsed conduits, and, astonishingly, the same cylindrical lantern lens shattered into pieces on the floor. Even buried, the optical system had once existed here as well. Back at the surface, the portable receiver confirmed that the weak 171.8 biometervarberts beacon continued to operate. Yet its source did not come from beneath their feet. When they aligned the antenna toward the horizon, the signal strengthened dramatically. The origin lay farther west, beyond their reach, suggesting a third station still alive near the sea. That evening, with the sky glowing violet over the dunes, the team plotted the cable path on their digital maps. Extrapolated across historical data, the line intersected what was once a colonial military airfield near the coastal ridge. The implication was staggering. The desert beacons, and the coastal base had been parts of a single operational network. As they packed their equipment, the radio operator noticed a sudden fluctuation on the receiver. The clean pulse that had been repeating at perfect intervals now carried an additional burst, a shorter signal inserted midway through the cycle. It lasted less than a second. When decoded, it resembled a timestamp, a string of 6 digits corresponding to the current UTC hour and minute. Somehow, the system had registered their presence and responded. The scientists exchanged uneasy glances. It could have been coincidence, interference, a cosmic ray glitch, yet the timing was flawless. For a network abandoned for over 60 years, the precision was impossible to ignore. Something, somewhere, was still synchronizing the chain. Under the starlight, they stood in silence beside the half-buried dome. The air was perfectly still, carrying only the faint hum of their instruments. Beneath their boots lay one of history's lost machines, still whispering across the desert, linking dead stations in a language of numbers and timing pulses. And on the oscillograph screen inside the tent, every 62 seconds, the signal returned, unwavering, deliberate, alive. Back at their field station, surrounded by printouts and archival scans, the researchers began piecing together the fragments of a forgotten history. The name semaphore appeared repeatedly in the recovered documents, but another term surfaced in the margins of several memos: Expérience Lucie. It seemed to describe a classified experiment, a collaboration between French civil aviation and military communications engineers, dating from 1956 to 1959. According to one incomplete technical abstract, Lucie was intended to build a self-synchronizing global navigation grid, an array of terrestrial radio beacons that could triangulate an aircraft's position anywhere, even beyond radar range. Each lighthouse emitted an ultra-stable frequency modulated by a precise timing code. When at least 2 stations were detected simultaneously, the receiver could compute its coordinates automatically. The optical lens atop each tower, once assumed decorative, served a crucial purpose: alignment calibration. During installation, technicians used sunlight to check azimuth precision by measuring reflected beams between stations. The concept was revolutionary for its time: a proto-satellite network without satellites, entirely grounded in Earth's geometry. But its ambition came at a cost. Documents showed escalating budgets, logistical failures, and growing political resistance as decolonization spread across North Africa. By 1959, the program had quietly ended, overshadowed by new radio navigation systems in Europe. No public record of Lucie remained after 1960, yet something didn't add up. The cables, materials, and faint electrical continuity proved that the physical infrastructure had never been dismantled. Instead, parts of it had been abandoned in working order, still tethered to forgotten coastal substations that continued feeding a maintenance current, just enough to preserve the signal generators. The system had been designed with extraordinary redundancy. As long as a single transmitter remained linked to a power grid, the network would keep circulating its reference pulse in a closed loop. Cross-referencing the data, they found evidence that the 171.8 MHz beacon they'd been detecting wasn't a navigational channel at all. It was a temporal reference, a kind of heartbeat, meant to synchronize the timing of all beacons in the chain. It transmitted a single packet of phase-corrected data every 62 seconds. If one station failed, others would recalibrate automatically, sustaining coherence across thousands of kilometers. The deeper they delved, the more awe replaced confusion. Lucie had been an engineering marvel. Analog computation, atomic time standards, long-range phase locking decades ahead of its era. The fact that its residual signal still pulsed through the desert after 70 years testified to the resilience of its design. But the moral dimension was harder to ignore. The project had been developed under military supervision, during a period of secret weapons testing. Its intended purpose, though officially navigational, may have included the coordination of aircraft monitoring atmospheric nuclear trials. The choice of remote desert sites, far from civilian eyes, made perfect sense. The team reviewed the last lines of one faded memo, dated 1959. In case of termination, leave the synchronization circuits intact until final directive. Manual shutdown required at coastal node. That directive had never come. The coastal node, the final beacon in the chain, must still be running on automatic mode, perpetually transmitting the same pulse it had since the day the engineers packed their equipment and left. It was no miracle, no mystery of time or weather, just the mechanical persistence of a forgotten machine. The desert had buried the hardware, but not the signal. As the researchers looked again at the oscillograph's faint trace, now stable and rhythmic, they realized they were listening to the echo of mid-century optimism, the heartbeat of an obsolete dream that refused to fade. The system had survived not through magic, but through the one force more enduring than empires or sand, engineering done too well to die. By the end of the 4th week, the team returned to L-13. The desert air had cooled, and the horizon glowed with the copper hue of the setting sun. The tower, freed from most of its sand covering, looked strangely complete now, no longer an anomaly, but a monument. They had confirmed its lineage, decoded its pulse, and mapped its role within the forgotten Lucy network. Only one question remained. Why had the system never truly shut down? At dusk, while the equipment was being packed, one of the engineers climbed the outer staircase to take final photographs. As the sun touched the horizon, its light struck the Fresnel lens. For a fleeting moment, the prisms aligned perfectly, refracting a beam that leapt westward, a clean, narrow band of fire vanishing into the desert haze. It wasn't mystical or random, it was geometry. The tower's optics had been calibrated decades ago to face the coastal node, hundreds of kilometers away. The sunlight completed a line that had not been broken since 1958. Moments later, the receiver at the base registered a subtle change. The 171.8 mmHz pulse shifted in amplitude, as if acknowledging the reflection. For 70 years, the system had run blind, repeating its synchronization cycle without verification. Now, by coincidence or alignment, the sequence had closed a full loop of communication between the inland beacon and its forgotten counterpart on the coast. The researchers stood in silence as the oscillograph traced its perfect rhythm. Every 62 seconds, the signal rose and fell with mathematical precision. There was no hidden intelligence, no message, only the echo of a network designed to unite the sky with the ground. Yet its endurance felt almost human. Stubborn, patient, quietly faithful to its purpose long after those who built it were gone. In their final report, they wrote plainly, "Station L-13, constructed between 1956 and 1958 as part of the French terrestrial navigation system Experience Lucy, remains operational in passive synchronization mode. Power likely supplied through residual coastal feed. No further hazard detected." The Lighthouse had never guided ships. It had guided time itself, holding a reference heartbeat for aircraft that would never come again. When the program ended, the pulse continued, looping endlessly through neglected circuits beneath the salt. That evening, before sealing the site, they powered one last recording. The lens caught the final gleam of daylight, sending a narrow glint along the same westward line traced in the documents. It wasn't bright enough to be seen from afar, but on the monitors it was unmistakable, the original design still functioning as intended, closing the synchronization path for perhaps the final time. No one spoke. The air smelled of iron and dust. In the silence, the desert seemed to listen too. Then, almost imperceptibly, the signal flattened, its amplitude decaying to a steady baseline. The system had completed its cycle. Nobody knew whether the coastal transmitter would ever answer again, or whether the brief resonance they witnessed had been the last flicker of a dying machine. But the record was clear. The beacon in the desert had worked precisely as designed, surviving beyond politics, beyond memory, beyond even purpose. It wasn't a mystery after all, just the afterimage of human precision, glowing faintly in the emptiness. And as the team drove away under the first stars, the tower's lens still caught one final reflection of their headlights, a small, perfect spark at the edge of the dunes. If you want to know where they found the second lighthouse, make sure to subscribe. The next story is already in progress.